So, good evening all. Welcome to SAKALAVIDYA YouTube channel. Okay, am I audible to you, all of you? Voice is clear? So you need to chat. Voice is clear or not? Okay, Prasanna, Swati Singh, Samhita, Sumant, Sharma, Kartikeya, Chaturvedula. Okay, right. Vamshi Prakash, Surya Prakash, Vamshi Krishna Yadav, right. Akshay Diman, after a long time. Taufik. Ah, yes, okay, thank you. Right. Okay, some of the viewers are actually giving complaining that they are not getting good voice. That's why I asked you whether the voice is clear or not. Okay, thank you now. Thank you. So actually, just in Vaishnavi. Okay, Dinesh, Mustafa, right? Manohar, Ajay Kumar. Today many new viewers are there. So new viewers, Saranya. Okay, Balu, right? Govind, clear. So inform to your friends also. Today the class, now it's actually weather is changing. Our class may continue 30 minutes or 1 hour, I don't know today. Just already here gentle breeze is coming. So now Srija, Nara Dinesh. Yes, where can I get WhatsApp link? We don't have any WhatsApp link actually. Below description is there. In the below description we have that is Telegram link. Click it, that's all. Okay, Kadri. Mustafa, welcome. I observed you, don't worry. Okay, today class is introduction class, that's why no problem actually any, or they can watch even offline also, right? So let me start. The chapter is maybe 1 or 2 marks in the examination, or it may be useful for even vector chapter also. This concept is right. Okay, first point, write down first point. Yes, today DCs and DRs. Okay, let alpha, beta, gamma be the angles made by good afternoon, made by a line with positive directions of coordinate axis coordinate axis means x-axis, y-axis and z-axis. Okay, axis. Then cosine angles of alpha, beta, gamma, that means cos alpha, cos beta, next cos gamma, are called direction direction cosines of a line denoted by L, M and N, where L is equal to cos alpha, M is equal to cos beta, and N is equal to cos gamma. So this is the definition of the direction of the cosines. Understood now? Direction of the cosines. So that means, for example, let alpha, beta, gamma be the angles made by a line with the positive direction of coordinate axis. If you take cos alpha, cos beta, cos gamma are called direction cosines of a line. So they are denoted by L, M, N. So where L is equal to cos alpha, M is equal to cos beta, N is equal to cos gamma. Then we write direction cosines as DCs also. Shortly in this lesson we use DCs. DCs are L, M, N. So we write like this in this chapter. Okay, now the relationship between L, M, N, that's very important. Syed Mustafa Qadri sir, from which book you are solving the sums? Okay, that you will get to know after later. Today only you are the new joining, isn't it now? So later you will know it. Today we shall discuss about this direction cosines. Now let us move to the second page now. Second concept. See, we know that if L, M, N are the DCs of a line, then in that first point L square plus M square plus N square equals to 1. So L square plus M square plus N square is equal to 1. Govind, absolutely correct. Next, second point, if you put L for cos alpha, M for cos beta, N for cos gamma, you get this relation also. Cos square alpha plus cos square beta plus cos square gamma is also 1. So now substitute cos square alpha is equal to 1 minus sin square alpha, cos square beta is equal to 1 minus sin square beta, and next cos square gamma is equal to 1 minus sin square gamma. Then what do you get now here? If you substitute cos square alpha is equal to 1 minus sin square alpha, so we get sin square alpha plus sin square beta plus sin square gamma equals to 2. So this relation we shall get it. This is about the direction cosines of a line. Very simple. If L, M, they are denoted by L, M, N, L square plus M square plus N square is equal to 1. L is equal to cos alpha, M is equal to cos beta, and N is equal to cos gamma. We have L square plus M square plus N square is equal to 1. Cos square alpha plus cos square beta plus cos square gamma is equal to 1. Whereas sin square alpha plus sin square beta plus sin square gamma is equal to 2, not 3. That is 2. And one more thing, it will be useful for even vectors chapter also. So please keep in mind. Because if L, M, N are the direction cosines of a line, Li plus Mj plus Nk is a unit vector. Because its modulus will be root of L square plus M square plus N square, that will be 1. So now here time is 4:09 itself only, it seems to be, but 4:14 I already get Hare Krishna. I could not get through about your chart. So next now, third point, let us discuss third point. 3 real numbers, 3 real numbers, 3 real numbers A comma B comma C are said to be direction ratios of a line, provided if A is to B is to C equals to L is to M is to N, L is to M is to N, where L comma M comma N are the DCs of a line, direction cosines of a line. Any 3 real numbers A comma B comma C are said to be direction ratios of a line, provided that their ratio A is to B is to C should be equal to the direction cosines. For example, direction cosines are actually unique, but whereas direction ratios may not be unique. For example, A comma B comma C are the direction ratios of a line, then 2A, 2B, 2C also direction ratios of the same line, even 3A, 3B, 3C also. So that's why one more thing here, A square plus B square plus C square does not equal to 1, absolutely correct. Here one more thing we need to remember, that A square plus B square plus C square does not equal to 1. You must remember. This is very important thing. Right. Not equal to 0 because, and not equal to 1 also. So next, in that first point, if A comma B comma C are the DRs, direction ratios of a line, then KA comma KB comma KC, where K does not equal to 0 is a real number. K should not be equal to 0, real number. Are also direction ratios of same line. Right. So wait 1 minute, Hare Krishna, I will check. 4:14 exactly. I am following. Hare Krishna, where are you from basically? Right. Leave it now. Okay. So next, second point. For example, on a line, for example, 2 points are given. How to find out its direction ratios? So that means direction ratios of a line joining the 2 points x1 comma y1 comma z1 and x2 comma y2 comma z2 we need to find out now. Okay. Sir, why square root of x is equal to mod x? Okay, I will explain. Definitely I will explain. Later I will explain. So I will keep in mind quadri, definitely I will explain. Okay, if a of x1 comma y1 comma z1 and b of x2 comma y2 comma z2 b, say with that, are 2 points on a line, then direction ratios of AB are, we can write like this, very simple manner, x2 minus x1 comma y2 minus y1 comma z2 minus z1. So direction ratios of the line we can find out if, okay, AP. But here actually I will ask with my technical team, also discuss with the time, but I don't have the idea about that one, how to correct it. Okay, right. So now this is very important. If any 2 points on a line are given, then we are able to find out the direction ratios of a line. So that will be given by x2 minus x1, y2 minus y1, z2 minus z1. So in the similar fashion, even we can find out direction cosines also. And direction cosines of AB are, this we can write x2 minus x1 by distance between AB, that is say AB simple, comma y2 minus y1 by AB, next z2 minus z1 by AB. Because actually here AB is equal to root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Understood now? Okay. Right. Right. So now, next point. Third point. If A, B, C are the DRs of a line, if DRs of a line are given, then how to find out direction cosines of a line? So that means actually here see, first write down like this, A, B, C divide each here component by, divide by root over A square plus B square plus C square. So we get now like this, we get A by root of A square plus B square plus C square and B by root of A square plus B square plus C square and C by root of A square plus B square plus C square. Okay, this write down plus or minus, plus or minus, plus or minus. So these are the direction. Then DCs are, we can write like this, plus or minus A by root of A square plus B square plus C square and plus or minus B by root of a square plus b square plus c square and plus or minus c by root of a square plus b square plus c square. Okay. So for example, if you want to find out one example, see, direction ratios of a line is 2, 3, 4 for example. How to find out direction cosines? So you need to divide by root of, actually here 4 plus 9 plus 16, that will be root 29. So DCs are plus or minus 2 by root 29, comma plus or minus 3 by root 29 and plus or minus root 4 by root 29. So for example, these are the DRs, these are DCs. So we can find out like this. So 1 minute, I'll check it now. Okay. Right, now if direction ratios are given, you can find out. Narra, Dinesh, we don't have the idea about the physics and chemistry. Please concentrate on the class. Right. So next concept we shall discuss in that only. Fourth point. If suppose L, M, N are the direction cosines of a line OP and length of OP, distance from O to P. Let OP equals to R distance, R units. Then coordinates of P in a space are LR, MR and NR. LR, MR, NR. Okay. So next, fourth point. If L1, M1, N1 and L2, M2, N2, if L1, M1, N1 and L2, M2, N2 are DCs, direction cosines of two different lines, that means of two lines, then drs of another line, which is perpendicular to both the lines are. Okay, right. That means actually you can write m1 n2 plus m2 n1 comma L2 n1 minus L2 n1 comma this one L1 m2 minus L2 m1. So this is very easy, nothing but actually this is nothing but they are the components of the vector perpendicular to the vectors L1 m1 n1 and L2 m2 n2 itself only. So that means actually here L1 m1 n1 and L2 m2 n2 are the direction cosines of the two different lines. So we need to find out drs of the line which is perpendicular to the both the lines are given by m1 n2 minus m2 n1 comma L2 n1 minus L2 n1 minus n2 L1 m2 minus L2 m1. Okay, so you need to remember all these things. Simply you can solve the problems. So and also one more thing, if the direction ratios or direction cosines of a line are given, we can find out angle between them also. That's in vectors we have discussed, that is the scalar product, cos theta concept. The same concept also we will explain here. Definitely probability chapter I will explain, that is P and C both are same. So if you go through the P and C, okay. Now let me move to the next concept, fifth one. So let theta be the angle between two lines whose drs are a1 comma b1 comma c1 and a2 comma b2 comma c2, then first point cos theta write down, cos theta. So cos theta is equal to, what do you write now here, a1 a2 plus b1 b2 plus c1 c2. So dot product means what is the cos theta, a dot b by mod a mod b. That concept we need to do it now. Okay, right. Upon, so modulus of this is actually root of, you will get a1 square plus b1 square plus c1 square under root of a2 square plus b2 square plus c2 square. For example, instead of direction, screen is not clear. I think screen is clear. Yes. Put 360p or go and come back. For example, L1 L1 M1 N1 and L2 M2 N2 are the direction cosines of a line. Directly we can write the cos theta is equal to like this. Simply L1 L2 plus M1 M2 plus N1 N2. Understood now? Okay. Next, cos sin theta. Sin theta is equal to the cross product we can find out. So that is, you will be getting sigma B1C2 minus B2C1 whole square under root, okay, upon root of A1 square plus B1 square plus C1 square, root of A2 square plus B2 square plus C2 square. So for example, here direction cosines are L1 M1 N1 and L2 M2 N2. Okay. So that is equal to, you can write sigma M1 N2 minus M2 N1 whole square under root. So using these two formulae, we can find out the angle between the any two lines. If provided direction of ratios are given, even direction cosines are given, we can find out. In the fourth point, what is the J component? You check it. J component. Okay. I think today more than 25 to 30 new viewers are there. Everybody has to subscribe first. Yes, L2 N1 only I have given. L2 N1 minus L1 N2. That only I have written. Okay. Next, sixth point. Not sixth point, one thing, wait, 1 minute. So in that third point, if two lines are perpendicular, okay, definitely I will explain where shall we use direction cosines and direction ratios. Everything we have the applications. So without applications we won't study mathematics. If two lines are perpendicular, then so dot product between two vectors is equal to, yes, that's correct only, Saranya. Right. Then A1 A2 plus B1 B2 plus C1 C2 equals to 0. Or we can write L1 L2 plus M1 M2 plus N1 N2 equals to 0. So for example, if two lines are parallel, each other, then A1 by A2 B1 by B2 equals to C1 by C2, or L1 by L2 equals to M1 by M2 is equal to N1 by N2. N1 by N2. Yes. Okay. So these are the very important points need to be remembered. So let us move to the sixth point. Sixth point. If L1, M1, N1 and L2, M2, N2 are the direction cosines of two concurrent lines. Concurrent means they meet at one point. Two concurrent lines. They meet at one point. Concurrent lines. Then dr's of the lines bisecting the angles between them are. For example, L1, M1, N1 and L2, M2, N2 are the DCs of two concurrent lines, then DRs of the lines bisecting the angles between them are. So that we need some explanation. Let us explain first, then we shall move to the next concept. See, for example, okay, these two different lines are actually intersecting like this. Okay. For example, this is a line bisecting the angle between these two lines. This is another line bisecting the other line. Dotted lines. Okay. For example, say this is L, this is M. Say this line is P, this line is Q. Where P comma Q are the P comma Q are the angle bisectors between L and M lines. That means this angle is equal to this angle. So this angle equals to this angle. So two angle bisectors we shall get it now. Understood now? So now what we need to find out? We need to find out direction ratios of P and R. Direction ratios of P and Q we need to find out, are given by, for example, the direction cosines of L line is L1, M1, N1, whereas direction cosines of M line is L2, M2, N2. This is space, not a plane. This is a space. So they are given by direction ratios L1 plus or minus L2, comma M1 plus or minus M2, comma N1 plus or minus N2. Okay, that means here actually two types of angle bisectors we shall get it. One is acute angle bisector, other one is obtuse angle bisectors. Obtuse angle bisector. For example, if this angle is actually acute angle, obviously this angle will be obtuse. For example, this angle is acute. This will be 180 minus theta, obtuse angle. This will be obtuse angle. Obtuse. So two types of the angle bisectors we shall get it now. Yes, Niviredi, absolutely correct. That also we are going to discuss. This is the concept of the right. So now here are given by L1 plus or minus L2, comma M1 plus or minus M2, comma N1 plus or minus N2. Okay. Next, now this is first point in this one, the sixth first point. Second point under sixth, direction cosines of acute angle bisector. Acute angle bisector are L1 plus L2 upon 2 cos of theta by 2, where theta is the angle between the lines, acute angle, M1 plus M2 by 2 cos theta by 2, comma N1 plus N2 upon 2 cos theta by 2. Next, third point, direction cosines of the obtuse angle. Direction cosines of the obtuse angle. Direction cosines of obtuse angle bisector are L1 minus L2 upon 2 sin of theta by 2, M1 minus M2 by 2 sin theta by 2, N1 minus N2 upon 2 sin theta by 2. So these are the concepts regarding to the angle bisectors. Okay. Next point is seventh point. And the seventh first point. If the projections of a line of length, this is very important, of length d, small d, on the if the projections of a line whose length is d on the coordinate axis are d1, d2, d3 respectively, then d1 square plus d2 square plus d3 square equal to d square. Suppose the projection of a line on x-axis is length of the projection on x-axis d1, length of the projection of a same line on y-axis be d2, on z-axis be d3. For example, if the length of the line is d, line segment is d, then d1 square plus d2 square plus d3 square is equal to d square. Suppose instead of coordinate axis, coordinate plane is given, then the formula will change. The formula is actually we need to write d1 square plus d2 square plus d3 square is equal to 2 times dd square, 2d square. We need to write it. Kurumsetti Arish, don't put this kind of symbols. Okay, our regular viewers, please instruct the new viewers. Second concept, if the projections of a line of length d on the coordinate planes, that means xy plane, yz plane and zx plane, are d1, d2, d3 respectively, then d1 square plus d2 square plus d3 square equals to 2d square. Actually, in the examination, this d length will be given and you are asked to find out d1 square plus d2 square plus d2 square, d3 square. But we need to remember whether on the coordinate axis projections or on the coordinate planes. This is important. So you need to concentrate on this one. Coordinate axis means simple d square you will get. Coordinate planes means 2 times d square you will get it. That you need to remember in the examination. Okay, now right. Okay. One minute. Let me complete. Right. Suppose, say, this is A point, you say, this is B point. This is a line joining A point and B point. See, A coordinates are, you say, x1, y1, z1. Whereas B coordinates are x2, y2, z2. So, AB is a line joining the points x1 comma y1 z1 and x2 y2 z2. Then we need to find out, for example, suppose another line. This is suppose this is L line, this is M line. Projection of line L on M we need to find out. Say for example, this is C point, this is D point, this perpendiculars. So projection means the length of CD you need to find out. For example, if the direction cosines of M are given L comma M comma N, then we need to find out this projection CD we need to find out. The CD is given by CD is the length. That's why you need to take mod L multiplied by x2 minus x1 plus M multiplied by y2 minus y1 plus N multiplied by z2 minus z1. So this is the formula to find out length of the projection of a line joining the points x1, y1, z1, x2, y2, z2 on the line whose direction cosines are L, M, N. This is very, very important. Even this will be very important for the vectors also. In vectors also, length of the projection of the line on the other line or the shortest distance also. So that we will discuss in the vectors chapter. Okay. So now let us move to the concept now. So next write down. That is the third point now. Third point. The projection of the line, joining two points, okay, 2 points A x1 y1 z1 and B x2 y2 z2 on a line whose direction cosines are L, M, N is, that's given by modulus of L multiplied by x2 minus x1 plus M multiplied by y2 minus y1 plus N multiplied by z2 minus z1. This you will get it formula. Right, Chava Lata Chowdhury, you are new to my class. I haven't seen, first time. Right. So now let us move to the next concept. We should not waste our time. So next concept is eighth concept. Eighth one. If L1, M1, N1, L2, M2, N2, L2, M2 are DCs of two lines, then we have one important relation. What is the relation? Means L1 square plus M1 square plus n1 square multiplied by L2 square plus M2 square plus N2 square and minus of L1 L2 plus M1 M2 plus N1 N2 whole square equals to, we can write sigma M1 N2 minus M2 N1 whole square. This relation we have. Okay, next point. Now ninth point. This point I think everybody knows. Everybody knows. If the edges of a rectangular parallelopiped rectangular parallelopiped or ABC, then the angle between four diagonals are given by cos inverse of plus or minus a square plus or minus b square plus or minus c square upon by a square plus b square plus c square. Okay, this we need to take modulus, mod of plus or minus a square. Shri Krishna Yadav, yesterday actually your father spoke with me. See, try to concentrate, don't worry about the results. Okay, right. Here one important thing we need to remember, that plus or minus a square plus or minus b square plus or minus c square means we need not take plus minus at a time. So that means actually in the numerator all the three signs are positive or negative. That means we need to consider like this, plus minus like that, but we should not consider plus minus. You remember, that's very important note. So important note you remember in this case. What is the important note means? Important note, in the numerator all the three signs means symbols, signs are not either positive or negative. This is we need to remember. So now, for example, instead of rectangular parallelepiped, cube is, if you consider cube, in a cube all the sides are equal. A is equal to B is equal to C. So that means what is the angle between the diagonals? For that we can write it. If you put A is equal to B is equal to C is equal to A, you get, what do you get now? A square minus a square minus a square by a square plus a square plus a square. You will be getting, that is cos inverse of 1 by 3. Cos inverse of 1 by 3. That is very important problem. You might have solved for LAQ in board examination also. So that we will write it now. So now the first point under this, first point, angle between any two diagonals of a cube is cos inverse of 1 by 3. Even this is useful for vector chapter and this chapter. For example, angle between the diagonal of a cube with the diagonal of the face of a cube. So that is also there, you remember. Second point, angle between diagonal of a cube and diagonal of a face of a cube is cos inverse of root of 2 by 3. These are actually standard results. So I explained to you in the seminar session also, these are the actually standard results we need to remember directly. These are questions based on memory based questions. That's all. Angle is the 90 degrees. That's not correct. Angle between the sides is 90 degrees. Okay, next now the important points. This will be useful for the solving the problems. And next concept write down, that is tenth point. If alpha, beta, gamma, delta, alpha, beta, gamma, delta are angles made by a ray with four diagonals of a cube, because the cube has four diagonals, parallelepiped also four diagonals of a cube, then cos square alpha plus cos square beta plus cos square gamma, plus cos square delta equals to how much? Cos square alpha plus cos square beta plus cos square gamma plus cos square delta. Anybody? So you can chart it. Anybody? I am waiting for your answer. Right. So Basavaraj Kistaya, if you are not interested, you can leave. 4 by 3, absolutely correct. 4 by 3 is absolutely correct. 4 by 3, not 1. 4 by 3. Yes, 4 by 3. Or you can remember like this also. Sin square alpha plus sin square beta plus sine square gamma plus sine square delta equal to how much? Equal to how much? That means very simple. Cos square alpha means 1 minus sine square alpha, you can write. This will be 1 minus sine square beta plus minus 1 minus sine square gamma plus 1 minus sine square delta equal to 4 by 3. Now sine square alpha, you can say sigma, no problem, equal to, take that side, 1 plus 1 plus 1, 4 minus 4 by 3, 8 by 3, that will be 8 by 3. So write down this is 8 by 3. Right. Right, Serenia, Surya Teja, Madhurima. Yes, yes. Okay, right. Next, 11th point. 11th point. If the DCs of lines are connected by the relation, are given by, they are connected by the relation. What are the relation? Given by AL plus BM plus CN equals to 0 and FMN plus GNL plus HLM equals to 0. That means that the direction cosines of the two lines are given by these two relations. Then we are able to find out the direction cosines of the each line, and next we are able to find out the angle between the lines also, or we are able to decide the condition for the perpendicularism, condition for parallelism. That's very important. We need to check it now. In that first point, perpendicular, when do we say perpendicular? That means angle between them is 90. So perpendicular means then F by A, G by B plus H by C equals to 0. You need to verify this. For example, if the relation is given like this, you need to verify this condition. F by A plus G by B plus H by C equals to 0. Then we say that the angle between them is 90 degrees. They are perpendicular each other. Second point, parallel. When do we say parallel? Then root of AF plus root of BG plus or minus, it may be, no problem, root of CH equal to 0. If these two, with the help of these two conditions, we say that perpendicular and parallel. If the two lines are perpendicular, condition, that's perpendicularism condition. Next one is the parallelism condition. So next we go for 12th one. Today we discuss all the concepts. Tomorrow we shall go for the problems. Yes, proportional. Proportional is different here, right? Tomorrow we'll discuss the examples also. Yes. L square plus M square minus N square, 2LM plus 3LN plus 5ML, like that. That is the examples. So now the 12th one. the DCs of two lines are connected by or given by relations, or given by AL, this is same, plus BM plus CN equals to 0, but here changes, and UL square plus VM square plus WN square equals to 0 are perpendicular. Condition need to be written. Perpendicular. Then V plus W of A square plus W plus U B square plus U plus V C square equals to 0. Actually, this is the 7 marks problem in the board examination. Okay. Second point, parallel. Then A square by U plus B square by V C square by W equals to 0. Yes, for every competitive entrance examination, it will be useful. Dishwank, you are absolutely correct. So next now, thirteenth point, equation of a line passing through a point x1 comma y1 comma z1 and having drs ABC is. That means now we are able to find out the equation of the line passing through a point, that means Cartesian equation, x1 comma y1 comma z1 and having its directions cosines, direction ratios ABC is. So that means, so this is the formula to find out equation of the line, x minus x1 upon A equals to y minus y1 upon B equals to z minus z1 by C. Actually, this is the Cartesian equation of a line in space, not a two-dimensional formula. So next, 14th formula. How to find out equation of a line passing through the 2 points in a space? Equation of a line passing through x1 comma y1 comma z1 and x2 comma y2 comma z2 is x minus x1 by x2 minus x1, because x2 minus x1 is A. Direction ratios, y minus y1 by y2 minus y1. This is z minus z1 by z2 minus z2. If you take only first two, this is the two-dimensional you will be getting. Okay. Even actually this is very useful for JEE mains examination also. In JEE mains examination, vectors and 3D geometry is actually connected chapter. Okay. Next point. Any point on the line, passing through x1, y1, z1 and having DCs LMN is in the form of, that means parametric form, is in the form of x1 plus LR comma y1 plus MR z1 plus NR, where R is the parameter. That means if any one point on the line is known, exactly. Right. Wait. Dishwank, wait. Let her go to hell. Yes. So that means actually you see x2 minus x1 by x2 minus x minus x1 by, you can write like this. Where is the L? I will explain, don't worry. See, x minus x, equation of the line is x minus x1 by A means L write down here. Y minus y1 by M write down. Z minus z1 by N write down. Suppose this actually ratio. If you say this is some value R, say we get x minus x1 equals to L into R LR. So we can write x is equal to x1 plus LR. Similarly, we get y is equal to y1 plus MR. Z is equal to, we get z1 plus MR. That's all. Understood now? Okay. Thank you, Prudvi. Thank you. So don't worry, if anybody not interested, actually let them be actually deleted, discarded from our classes. Don't worry. Right. Sixteenth point. This is very important. So this is the standard result, standard bit, memory based. It should be, you need to remember this one. Right. If a variable lines in two adjacent positions has DCs, direction cosines, LMN and just little bit change, L plus delta L, M plus delta M, comma N plus delta N, and delta theta, the small angle, delta theta is the angle between the two positions, between the two positions, between the two positions, then delta L whole square plus delta M whole square plus delta N whole square equals to delta theta whole square. It has the proof. This proof is actually 7 marks problem. Even if you go for higher classes, that means if you go for even degree or PG classes, this will be the one of the important question to be discussed. So here actually in this stage, intermediate stage for Eamcet or JEE means, this is the standard bit. Just remember, that's all. In the examination you need to select the option, that's all. Delta L whole square plus delta M whole square plus delta N whole square is equal to delta theta square. I hope everybody understand. So these are the concepts you need to remember. Direction ratios, direction cosines are very simple chapter. So tomorrow we shall go for the problems. So okay, I hope everybody have practiced. If you have any doubt, you can ask me. 5 minutes I can spend for you. So now ask the doubts. Prasanna, Suma, Narendra, Murthy. Yes, second semester. Prithvi, exactly correct. Again, whatever mathematics you study at intermediate level, that will be useful for your classes. Even you go for even any post-graduation course or BTech course, this will be very useful to you. Understood now? How many marks? Okay, it may be 1 to 2 marks actually, but we need to discuss it. Even 1 mark is also very important for us. So we should not leave a single mark. Even mathematical induction also. Last time actually applications of DCs and DRs. Applications of DCs and DRs means total this comes under vector algebra itself only. The 3D can be dealt with the help of vectors also, we can dealt it. If I had doubt about 12th point, what about UVW? Because I forget, sir, you can explain 12th point. UVW are the constants, that's all, constants. In the 11th point I have taken other constants. In the second one I have taken UVW are the constants itself only. Just like numbers, they are the real numbers. Okay. Here 2 Hare Krishnas coming. Yada Hare Krishna, some other Krishna Kotla. Sir, title you don't remove me from ID option without any mistake you had me. What is your ID? First of all tell me. Now I will unhide you. Yes. After completion of this chapter, you go to the plane. You go to the plane means you will fly the plane. Planes already started today onwards. Where we use DCs and DRs. So DCs and DRs will be used in vector algebra. I told you several times. 3D geometry we will use it. Right. What is Kirtana Kotla? What do you need? What do you want? Okay. Okay, when we use DRs, sir, DRs means in 3-dimensional geometry, when you are asked to find out equation of a line, then DRs is used. Equation of a line, equation of a plane, you need to find out, because we are living on a globe, Earth is a space. In that space actually we have the spherical geometry, not plane geometry. In the spherical geometries, as far as spherical geometry is concerned, actually we treat 3-dimensional. Whenever 3-dimensional comes in two-dimensional, generally we use, if you want to find out equation of a line slope, we will use the concept there. But here we don't use the slope concept. So that here we use DC's DRs to find out equation of a line, equation of a plane we can find out. With the help of that we develop the concepts, applications that will be applied to the even to study astronomy. Understood now? Total astronomy is based on this one itself only. Latitude, longitude and everything can be discussed with the help of this. Okay, first one problem. One problem. Okay, tomorrow we'll discuss the one problem. So problems will be very simple, you know. Okay. Chandana. Okay, sir. Thank you. Thank you. Thank you. Thank you. Okay, you got the CSC seat in Geeta? Murthy? Got it? Okay. Okay. So thank you, Vanada. Okay, we will meet you today. Is actually so far no for failure. Successfully you have completed today class. Thank you. Bye bye. See you.